Hi everybody, this is Dino Chris from Prehistoric Facts. This is a special episode, and I actually have chosen two dinosaurs that I'll be talking about. And the first one I'll be talking about is Falcarius. Now, Falcarius, in Greek, it actually stands for sickle bearer, and found in North America, basically in Utah. Early Cretaceous, 130 to 125 million years ago. 13 feet long, probably 500 pounds, and it's a plant eater. And the distinguishing features of Falcarius are basically its elongated neck, kind of chisel-like teeth, and long claws on its hands. And when you look at the skeleton of Falcarius, you would actually think, oh, it's a predator. It's a predator. It looks like a raptorial dinosaur, you know. But you see, Falcarius is kind of that one of those missing links of basically a transition from meat eating to plant eating. So basically, it's going from a carnivore to a herbivore. So that actually is a very, very interesting thing about Falcarius. And so Falcarius probably was feathered, probably was covered in feathers, probably would have actually been using those feathers for display and probably thermal regulation, that kind of stuff. But there's still not that much of evidence to prove that. But even though I think it's actually talking about that. And this dinosaur was actually discovered in 2005, so almost 10 years ago. So this is actually a dinosaur that's been, for discovery, it's almost a decade old. So when we actually look at Falcarius, it's actually one of those kinds of dinosaurs that you would actually think like this is a weird transition from meat eating to plant eating. But even though, since that, Falcarius actually comes from a group of dinosaurs called Ceratosaurus. So this kind of big family of dinosaurs is actually the same family that Tyrannosaurus belonged to, Dromaeosaurs, Therizinosaurs, Oviraptorids, and Ornithomimids. And so those are all dinosaurs that belong in the Coelurosauria family, and those are all families of dinosaurs that basically belong in Coelurosauria. But where does Falcarius actually fall into this? There's a huge debate on whether or not Falcarius is a Therizinosaur or is it an Oviraptorid. And the reason what we can actually say is that probably both Therizinosaurs and Oviraptorids started out in North America. So they probably started out in North America and they migrated towards Asia. And then when we actually see but basically when we actually look at like other kinds of dinosaurs that actually are from North America but probably had actually Asian ancestry, like the Tyrannosaurs and the Ceratopsians, those are all dinosaurs that actually had Asian ancestry, and so those dinosaurs were basically migratory, pretty much Asian immigrants to North America during the Mesozoic. Whereas Falcarius probably was actually one of those dinosaurs that probably started out as basically a link between Oviraptorids and Therizinosaurs. And when we look at the foot of Falcarius, you actually see that the fourth toe, or at least the first toe, which mainly is the toe where it's actually becoming vestigial, almost theropod dinosaurs, it's actually getting longer, so it's actually trying to support more weight. When you're becoming a herbivore, you gain more weight, and so you add more weight to the legs, and so you would actually start to actually add more support to those legs. So your bones get thicker, and also you actually are adding a little bit more balance to your legs. So if you're going to add that fourth toe, then that first toe to get longer, then that's a very good situation that Falcarius is gaining a little bit more weight due to the fact it's eating plants, and herbivores are heavier than carnivores. That's basically how that goes. And so Falcarius during that time would have actually had other Coelurosaurian relatives that were living along with it. There were probably some Carcharodontosaurids that were probably roaming around, like Siach, those kinds of dinosaurs. Siach was actually living around during that time. There were some sauropods that were actually roaming around during that time as well. Ornithischians that were actually roaming around as well. Basically, iguanodontids, not really the duck-billed dinosaurs, because duck-billed dinosaurs didn't totally evolve until like the mid-Cretaceous. So since this is kind of early Cretaceous, we might as well actually just start thinking that this is actually what's going on. And the deposit, basically the formation of where Falcarius is actually found, it was actually the sediments support the idea that this was actually a natural spring. So it was a volcanic spring area. So basically, any animals that actually got so close to the natural spring and basically kind of actually inhaled the toxic gases that actually came out of there would have probably just died right on the shoreline of the spring, and thinking like that basically this is a freshwater pool, and basically would have actually had that kind of feel towards that animals. This is a natural place to drink, but basically it's basically a trap. So that's how it actually probably happened. And so Falcarius, basically with its extinction, is basically new plants, and also you add more dinosaurs that actually are actually gonna basically eating those plants a lot more than what it was actually supposed to do. So basically, probably Falcarius moved further north. The Falcarius probably moved further north and kind of crossed the land bridge to get to Asia, and so that's probably how they actually got to Asia. And actually, some of the Therizinosaurs actually came from are basically like Therizinosaurus and Albertosaurus. Probably actually all are basically Asian, and so it's basically an American ancestry. And so, alright, the next dinosaur I'll talk about is Proceratosaurus. And Proceratosaurus basically is a type of tyrannosaurid, so it's going to have the same characteristics as tyrannosaurs do, like the D-shaped cross-section of the teeth. That's a big characteristic for tyrannosaurs. And also it has a horn, like a little bit of a hornlet right on its nose. So, but whether or not it actually is part of the crest or part of a crest or otherwise, that's how it actually is. In terms of the nose like crest on its nose. It's just basically it's still highly debated on whether or not this dinosaur belonged in Tyrannosaurs, but it basically, most of the evidence does support it belongs in the Tyrannosaurids. And Proceratosaurus means before Ceratosaurus, but even though because since and this dinosaur is actually found in the Middle Jurassic, it is found in Western Europe. Basically was 9 feet long and probably weighed 500 pounds. It's a carnivore, like the Tyrannosaurids, and basically Proceratosaurus is a basal tyrannosaur, meaning that this is a primitive form of a tyrannosaur, and that's why tyrannosaurs started out small. And so probably the common ancestor to all coelurosaurs were basically all coelurosaurid families probably started out 200 million years ago, basically the beginning of the Jurassic. So it's gonna be a big question of what kind of dinosaur would actually be the common ancestor towards coelurosaurs, to all coelurosaurid families. Was it a dinosaur that was similar into like Compsognathus or Ornitholestes? So that's always going to be a big question right there. And so Proceratosaurus, The reason why it is not a ceratosaur is basically the D-shaped cross-section of the teeth, and also the skull is very different from ceratosaurs, and also it's smaller than the ceratosaurus, and so this dinosaur has actually kind of had a much more stable skeletal structure to actually support this kind of dinosaur probably having bigger ancestors in the future, and that's the reason why Proceratosaurus belongs in Tyrannosaurus. And so Proceratosaurus was eating smaller dinosaurs, so it actually would, or smaller animals, basically like small mammals, and also probably amphibians, reptiles, and maybe insects. But they probably also fed on smaller dinosaurs, like baby dinosaurs, like some of the baby prosauropods or basilsauropods, basically like those kinds of dinosaurs. Probably some other kinds of dinosaurs that are probably would have eaten smaller dinosaurs, or probably would have eaten, basically. But it's just basically that the dinosaurs that have actually, the top carnivores during that time would have been the megalosaurs. So the megalosaurs were the top carnivores during that time. And so, and in Western Europe, that's where most tyrannosaurs kind of began. So, and Laurasia, basically Europe and North America were still connected at that point. And during that time of the Jurassic, and the Atlantic Ocean was still being formed. So that's how you actually start to see a differences in shapes and sizes of some dinosaurs, that kind of thing. And Proceratosaurus, with its extinction, is basically new predators, and also the new kinds of herbivores would have actually have been were getting bigger, and also probably and also the new predators like allosaurids and also ceratosaurs were coming in, and that's how that actually kind of all came to a halt for Proceratosaurus, and that's all I've got. And all right, that's it. And by the way, my presentation on Tyrannosaurs went very well on Thursday. I said last week that the presentation was going to be on the 9th, but it actually turned out that it got moved to the 11th. So that was the first one to go on Thursday. So that was pretty cool. And my visuals were pretty good. Showed my visuals, like my scaled down model of Stan the T-Rex, basically the skull of Stan, scaled model, the teeth of Tyrannosaurus Rex, Albertosaurus, and comparing them with like Giganotosaurus, Acrocanthosaurus, and Torvosaurus. And I used Tyrannosaurus Rex hand and also an Albertosaurus hand as well, and I used Albertosaurus maxilla as well to actually give my points about Tyrannosaurus. Why are they so different from other large Mesozoic theropods? That's basically how it goes. And so I wish I could have given you pictures, but I probably wouldn't have actually been able to. So that was actually a big problem there. So wish I could have asked somebody to take pictures, but basically that was going to be impossible. So, but just so you know, the presentation went well, and hey, maybe I might actually give the presentation to you sometime in the future. So hopefully it can be an extra at some point, an extra type of episode where I actually talk about Tyrannosaurs and where they fit in terms of the theropod family, and also what are the differences from Tyrannosaurs from like Allosaurids or Ceratosaurus or Carcharodontosaurids or the Abilisaurids, that kind of thing. But anyway, that's it for now. Now next week will be an answering questions episode, and I'll be back in my hometown, Wausau, Wisconsin, for basically winter break, because the fall semester right here in University of River Falls is coming to an end. I got finals to study, so that's actually going to be very important. But even though the answer questions episode will be next week, and so if you got a question about dinosaurs or any other prehistoric life, feel free to email me at dinocris71@gmail.com, or otherwise you can actually post the questions on the Facebook page, Prehistoric Facts with Dino Chris. Like the page, and you can actually post the questions in the comment section on any Facebook post. Keep in mind, keep your questions short and to the point. That's the reason why I like to keep. That's why I actually like to have these questions to be to the point, so that way I know what you're actually coming from. And also, you can follow me on Twitter at DinoChris. At Twitter, @CSGRALL. And I post pretty cool stuff on Twitter, so follow me on Twitter. And also, you can take care of the people around you, and also for you younger people out there, make sure to listen to your parents, your teachers, and your guardians. Those are the best motivation you can have for a good education. It's very important to have a good education, because with a good education, you get a good job in the future. Alright, that's it for now, and I'll see you guys next week.